Hello everyone. Our system is a learning platform based on the large language models designed to provide students with a space to complete exercise and receive tutorial support. And my part is proposed requirement and classifications. We classify system requirement into function and non-function requirement. Function requirement focus on the primary goal of projects, such as after students complete exercise, platform can correct exercise at once, utilize AI model to analyze exercise error rate, and offer guidance of solution strategy to students. The platform can also match students with suitable teachers for tutorials. Additionally, teacher can use AI to analyze students' situations on the platform. Based on this, they can help students make customized learning plans. And a non-function requirement. The focus on enhanced platform performance, such as reducing latency, ensuring that students receive the instant feedback after completing exercise, and improve model accuracy to better analyze students' weakness in order to offer more personalized AI explanations and exercise recommendations. And next page. The classification helps clarify deployment tasks and priorities and help us prioritize tasks during the development process, ensuring that the system can meet customer needs and is delivered as early as possible. And next one.
The next is proposed design. In our project design process, we choose the MVC, which is Model View Controller Architecture. And for those designs we discarded. First was the data flow architecture, as it became difficult to manage and maintain with complex data streams. Next, we abandoned the shared data design because shared data can lead to concurrency issues, increasing system instability. The layering architecture was also set aside due to high coupling between layers. And lastly, we did not adopt SOA, which is service-oriented architecture, because the communication overhead between services did not meet our high-performance requirements. Then we finally choose the MVC architecture. The MVC architecture, in MVC, the user uses the controller, and then controller manipulates the model, and then the view will be updated. The MVC promotes a clear separation between front and back-end development, allowing interface design and business logic to be developed in parallel.
Okay, next part is about the overview of models. When we talk about models in our project, it's important to understand the model-based software engineering and its value. For the problem, models can help us lower the complexity and avoid accidental problems so that we can focus the most essential ones. For the premise, an engineering model can help us understand the questions in different views with its abstraction and automation features. In results, the user models can help us reduce a lot of workload in the implementation stage. Next are three requirement models used in our project. The first one is ad hoc diagram, which is very abstract based on the requirements. It tells us what is the scenario and how each component interacts with others, and how well. The feature diagrams cover all features based on the requirement analysis, include main features, optional features, and non-functional features. Use diagram tells us how users engage with the system, offering an overview of the system at high level. The chart depicts various educational activities and how the system helps users to achieve their goals.
Next part is about architecture analysis and design. There are various architecture views and diagrams for our online teaching platform. Firstly, we have the 4+1 views model, highlighting four key perspectives. Logical view focuses on the functionality of the system. Development view addresses the software architecture, highlighting the key architectural components and their roles. Process view outlines the dynamic behavior and workflow of the system, and the physical view identifies the deployment, infrastructure, and the physical resources. Next, the following diagrams are extended through these four view models. Class diagram illustrates the system's object structure, and the object diagram provides a snapshot of the system state. And then the activity and the interaction diagram demonstrates the flow of actions within the system, from user login to access completion. And finally, the package and the deployment diagram outlines the system's physical architecture, showing how different components are organized and deployed across servers.
So the last part is basis for change assessment and acceptance determination. Changes are common during the design modeling process. To evaluate these changes, the first thing to do is to determine where these changes came from and then determine the impact on the next steps. For example, adding requirements will increase the features. Further change the original model structure, increasing the complexity. Therefore, the corresponding acceptance criteria must be formulated. Changes are required to improve the user experience and enhance the system function while minimizing the increase of complexity so as to reduce the design cost. When making a decision, we should first judge the priority of the changes and prioritize the changes of core functions. At the same time, it is necessary to consider the feasibility of these changes, such as whether the team has enough technical ability to implement these changes, and whether there is enough time and human resources to achieve the adjustment. Finally, validation such as A/B testing is needed to determine the effectiveness and stability of the change before making a decision. That's all. Thank you.